Hello everyone, welcome back to the AI Academy. Today, we are continuing our course on business analytics for management decision-making. In our last lecture, we covered data visualization. We went over its structure, key principles, and techniques, as well as some of the tools used for it. In today's class, we will focus on data analysis. We will look at topics like frequency distribution and histograms. We will also explore concepts like cumulative frequency, percentiles, cross-tabulations, and pivot tables. We will start our lecture by understanding the meaning of data analysis and what role it plays. In Excel, data analysis refers to a set of tools and techniques that help users manipulate, summarize, visualize, and interpret data. It provides a range of built-in features and add-ons that support various types of data analysis, from basic descriptive statistics to more advanced modeling techniques. Example workflow for data analysis in Excel. Let's say you want to analyze sales data to find the top-performing products and identify seasonal trends. First is clean the data, use remove duplicates, find and replace, and text to columns as necessary. Next is, summarize data, create a pivot table to calculate total sales by product category. Then comes, visualize trends, use a line chart to see monthly sales trends. Perform what-if analysis, use goal-seek to find the sales target needed to achieve a certain profit level. Finally, apply advanced functions, use forecast to predict future sales based on historical data. Let's discussing on how to create histogram in Excel with example. In the last lecture we learn about what is histogram, its components, its type and uses of histogram. We also learn its advantages and disadvantages. So today we will see how Excel creates it and how it is used in day-to-day life. Creating a histogram. The first step is to enter our data. For this we first open a new Excel worksheet. Then in column A, we list the scores we want to analyze as shown below. In column A we have data like 50, 60, 85, 65, 75, 95, 85, 60, 80 and 50. Step 2 is to create bins. In column B, we create bins, that is, ranges of scores, to group the data. For example, if we want to create bins for scores from 50 to 100 in increments of 10 as shown below. Step 3 is to insert histogram. For this first we select the data we want to use for the histogram, including both the scores and bins columns. Then go to the Insert tab. Click on Recommended Charts, or Histogram directly if visible. Choose Histogram from the options, and Excel will automatically create a histogram for our data. In Step 4, we can customize the histogram. Click on the histogram chart to see chart tools in the toolbar. Under Chart Tools, we can edit labels, titles, colors, and more. In this diagram we have edited the title. In this diagram we have changed the color of the histogram from blue to red. Let's see where to find the chart tools. Whichever type of chart we decide to go with, you will receive a set of tools to allow us to configure and design our chart however we want. At the top of the screen are the Design and Format tabs which sit under the title banner called Chart Tools. Let's take an example output. If our scores are distributed as in the table, Excel will create a histogram showing how many scores fall into each bin range, like so. This gives a quick visual of how the exam scores are spread across different ranges. In this the lower range taken is 50 to 59 and highest range is taken from 90 to 100. Once we click on Chat we want to create. Excel will create our histogram chart in few seconds. Here is an example of an Excel histogram chart based on a dataset of exam scores. The chart shows frequency distribution across different score ranges, with clear axis labels for score ranges and frequency to help visualize how scores are grouped within each range. This histogram shows that most data points that are frequencies of 3 fall in the ranges 60 to 69 and 80 to 89, meaning more values are in these score ranges. The lowest frequencies, 1, are in the ranges 70 to 79 and 90 to 100. This visualization helps us quickly understand which score ranges have the most or least occurrences in the dataset. Let's check statistical method for summarizing data. The table on the left side shows two columns. The first is upper limit. This column lists the upper limit of each range of values, which represent specific values in this case. In the frequency column, shows the frequency of each value, or how many times each value appears in the dataset. The data is structured as follows. 0 has a frequency of 0, meaning it does not appear in the dataset. 15,000 has a frequency of 50, that is, it appears 50 times. 25,000 have a frequency of 10. 32,000 have a frequency of 25. 52,000 have a frequency of 3. Histogram chart. The chart on the right side is a 2D histogram that represents this data visually. X-axis, that is, horizontal, shows the upper limit values, 0, 15,000, 25,000, 32,000, and 52,000. Each label on the x-axis represents a different value from the dataset. Y-axis, that is, vertical, shows the frequency, ranging from 0 to 60. This indicates how many times each value appears in the dataset. Each bar corresponds to a value from the table, with its height representing the frequency for that value. The bar for 0 has no height because the frequency is 0. The bar for 15,000 is the tallest, reaching up to 50 on the y-axis, showing that it appears the most frequently. The bar for 25,000 reaches up to 10, showing it appears 10 times. The bar for 32,000 reaches up to 25. The bar for 52,000 reaches up to 3, indicating it is the least frequent value after 0. This histogram makes it easy to see which values are more common in the dataset. The highest frequency is for the value 15,000, which appears 50 times, while 25,000 and 32,000 also appear frequently, with 10 and 25 occurrences, respectively. The value 52,000 is less common, with only 3 occurrences. This type of chart is useful for quickly identifying which values are the most or least frequent in a dataset. Let's take another example to understand data cumulative frequency. Before starting the calculation, first let's understand about cumulative frequency and how it is calculated. Cumulative frequency is a way of summarizing data by calculating the running total of frequencies up to a certain point in a dataset. It helps to understand how values accumulate across a distribution and is commonly used to create cumulative frequency tables and graphs, often making it easier to identify trends and analyze data distributions. Understanding cumulative frequency. Frequency refers to the number of times a particular value or range of values appears in a dataset. Cumulative frequency is the total count of all frequencies up to and including a certain value in a dataset. It is calculated by adding each frequency to the sum of the previous frequencies. It shows how data accumulates progressively across a dataset, making it useful for finding medians, quartiles, percentiles, and other cumulative statistics. How to calculate cumulative frequency. Step 1 is organize the data into a frequency table by sorting it into intervals or categories. If the data is continuous, group it into class intervals. Step 2 is calculate the frequency for each interval or category. Step 3, calculate the cumulative frequency by adding each frequency to the cumulative total of the previous frequencies. For example, consider a dataset that represents test scores. In this table, the cumulative frequency for the 20 to 30 range is 25, meaning that 25 scores are below 30. The final cumulative frequency is 60, which is also the total count of scores in the dataset. Uses of cumulative frequency. Percentiles and quartiles helps find data values at specific percentiles, example, 25th, 50th, 75th, by observing cumulative frequencies. In median calculation, the middle value can be identified by finding the cumulative frequency at 50% of the data total. Comparing distributions allows you to compare distributions by observing how values accumulate across categories or intervals. Identifying skewness means the shape of an ogive can indicate skewness. A steep rise at the beginning shows a higher concentration of low values, while a steep rise at the end shows a concentration of high values. Example of cumulative frequency in real life. Let's say a store tracks the number of items each customer buys. By calculating cumulative frequency, they can see how many customers bought up to a certain number of items, helping them understand typical purchase quantities. If they find that 90% of customers buy up to 5 items, they can use this insight for inventory and marketing decisions. Relative cumulative frequency is a variation of cumulative frequency that shows the proportion or percentage of the cumulative frequency relative to the total dataset. It provides a way to understand the cumulative distribution of data in terms of percentages, helping to identify trends and make comparisons within the data. Understanding relative cumulative frequency. While cumulative frequency gives a running total count up to a certain point, relative cumulative frequency expresses this as a percentage of the overall total. This is useful for understanding the proportion of data values that fall below a certain point, allowing us to analyze data distribution as a percentage. How to calculate relative cumulative frequency. Step 1 is calculate the cumulative frequency as described before. Step 2 is dividing each cumulative frequency by the total number of data points to get a relative cumulative frequency. Step 3 is multiply by 100 to express it as a percentage. It is optional. Example calculation. Consider a dataset of test scores and their frequency distribution. The relative cumulative frequency shows that 8.3% of the scores are below 10, 21.7% are below 20, and so on. The final cumulative percentage reaches 100%, as it represents the total data. Relative cumulative frequency graph. Similar to a cumulative frequency graph, ogive, a relative cumulative frequency graph plots the relative cumulative percentages against the upper boundaries of intervals. The y-axis represents cumulative percentages, and the x-axis represents the data values or intervals. The graph can show how quickly data accumulates and identify data thresholds or cutoffs. Example, the median is where the cumulative frequency reaches 50%. Applications of relative cumulative frequency. Percentile and quartile analysis, which is useful for determining percentile ranks, like identifying values at the 25th, 50th, or 75th percentiles. Comparing distributions, that is relative cumulative frequency, allows easier comparison between datasets of different sizes since it uses percentages. Interpreting data distribution, which helps to see the distribution concentration. Example, 80% of data points below a particular value. Example use case. Suppose a store tracks purchase quantities, and they find that the relative cumulative frequency shows 90% of customers buy up to 5 items. This insight helps them plan inventory, knowing that a small percentage of customers purchase larger quantities. Let's see the example of cumulative frequency distribution. This diagram displays a cumulative frequency distribution table along with a relative cumulative frequency line graph. In the table we can see the upper value that represents the upper boundary of each data interval, example 0, 15,000, 25,000, 32,000, and 52,000. The frequency shows the count of data points that fall within each interval. For example, 50 values are below 15,000, 10 values are between 15,000 and 25,000, etc. The cumulative frequency represents the cumulative proportion of data points up to each upper interval boundary. It is calculated by progressively adding the frequencies in each interval. And relative cumulative frequency is normalized version of the cumulative frequency, representing each cumulative frequency as a proportion of the total. For instance, 0.569 indicates that 56.9% of the data values are below 15,000. The line graph represents the relative cumulative frequency on the vertical axis and the upper value on the horizontal axis. The line begins at 0 and increases as it progresses through each upper value, illustrating the cumulative accumulation of data points. The curve's shape shows how the data is distributed across intervals. For instance, the steep rise between 0 and 15,000 suggests a significant portion of data points fall in this range. The line flattens towards the top, indicating that there are fewer data points in the higher intervals, with the cumulative frequency reaching 1, that is, 100%, at the maximum interval, that is, 52,000. This chart provides insights into the distribution of data, with most of it concentrated in the lower intervals. Before starting computing in percentile in Excel, let's understand first what percentile is. In Excel, percentiles are often used to determine the relative standing of a value within a dataset. It represents the position of a given value in a dataset in terms of what percentage of other data points fall below it. Here is a detailed guide on how to calculate percentiles in Excel, including using built-in functions and understanding their applications. To select percentile in Excel, we have to click on Formula, then More Function, then Statistical, and finally Percentile. Let's first understand percentiles. It tells us what percentage of a dataset falls below a certain point. For example, the 25th percentile is the point at which 25% of values fall below it. The 50th percentile, or median, is the point where 50% of the data lies below. The 90th percentile is where 90% of values fall below, and so on. They are useful in various data analysis contexts, such as identifying high or low performers in a group, understanding data distribution, and setting benchmarks. Let's discuss about percentile functions in Excel. Excel offers several functions to calculate percentiles. Percentile.exe in bracket, array, k, it returns the kth percentile of values in a range, where k is a number between 0 and 1, exclusive. Example equal to percentile.exe, A1, 100, 0.9, gives the 90th percentile of the data in cells A1 to A100. This function is best for datasets where we don't want the lowest or highest values that are 0% or 100% included in our percentile range. Percentile.inc, array, k, returns the kth percentile of values in a range, where k is a number between 0 and 1, that is, inclusive. Example equal to percentile.inc, A1, A100, 0.9, also provides the 90th percentile but includes 0% and 100% values in its calculation. This function is often used when we want to consider the entire data range, including extreme values. Quartile.exe, array, quart, a simplified version of percentile.exe, returning the first, second, and third quartiles, 25th, 50th, and 75th percentiles, but excluding 0% and 100%. Example equal to quartile.exe, A1, A100, 1, gives the first quartile, 25th percentile, of data in cells A1 to A100. This is helpful when we want to quickly calculate common percentiles. Quartile.inc, array, quart, like quartile.exe, but includes 0% and 100%. Example equal to quartile.inc, A1, A100, 3, gives the third quartile, 75th percentile, for data in cells A1 to A100. Calculating specific percentiles with examples. Let's say we have a dataset in the range A2, A21 and we want to calculate specific percentiles. Calculating the 25th percentile. Formula equal to percentile.inc, A2, A21, 0.25. This returns the value below which 25% of the data points fall. Calculating the median, 50th percentile. Formula equals percentile.inc, A2, A21, 0.5. This returns the median value, where half of the data points fall below it. Calculating the 90th percentile. This returns the value below which 90% of data points fall, excluding extreme values. Example use case. Suppose we have a list of student scores and want to determine which students fall above the 75th percentile, meaning the top 25% of scores. Step 1 is to calculate the 75th percentile with equals percentile.inc, A2, A21, 0.75. Step 2 is to use conditional formatting or a filter to highlight or list students with scores above this threshold. Visualizing percentiles. To visualize percentiles, consider creating box and whisker charts. Excel's box plot, or box and whisker, chart automatically displays the first, second, and third quartiles, helping us to see the spread of data and how each percentile fits into the larger dataset. Conditional formatting means applying conditional formatting to identify values above or below specific percentiles, making it easy to distinguish ranges within your dataset. Common percentile calculation errors. First are invalid k values which ensure that k, the percentile, is between 0 and 1. For example, 0.25 represents the 25th percentile, and 1 represents the maximum value in the dataset. Next is empty or text-filled arrays. The percentile functions work only with numerical data. Remove any non-numeric data from our range. Alternative approaches. If we need to calculate percentiles for different segments, like different groups, consider using Excel's data analysis toolpack for more advanced statistical function. Let's see the example to calculate percentile manually. Here we are calculating the 90th percentile for a series. N equals 96 observation. K equals 90. Formula is Nk divided by 100 plus 0.5. Rank of 90th percentile will be 86.9, which is round to 87. Then we have to check the value of 87th observation in the dataset. Let's take some more example. Computing percentile in Excel. Compute the 90th percentile for cost per order. Excel function for k power th percentile equals percentile.inc, array, k. Equals percentile.inc, b2, b11, 0.90. Using the formula percentile.inc, b2, b11, 0.90, in Excel, the 90th percentile for the given dataset is 122,110. This calculation is only for reference. We don't need to calculate it. It is done by Excel. Let's discuss about cross-tabulation. It is a method used to analyze the relationship between two or more categorical variables by creating a matrix, often called a contingency table. This table shows the frequency or count of occurrences for each combination of categories. Here's an example to understand cross-tabulation better. Suppose we have data on customer satisfaction, that is, satisfied, neutral, and dissatisfied, and the type of product purchased, electronics, clothing, and groceries. We want to understand if there is a relationship between customer satisfaction and the type of product. Cross-tabulation table. The table below summarizes the frequencies of each satisfaction level for each product type. The satisfaction levels are represented as follows. Dissatisfied is yellow. Neutral is blue. Satisfied is red. Each cell represents the count of customers for a combination of satisfaction level and product type. For example, 50 customers are satisfied with electronics, 30 with clothing, and 70 with groceries. The last row and last column are marginal totals, which help in calculating percentages or proportions. Here is a stacked bar chart representing the cross-tabulated data of customer satisfaction by product type. Each bar corresponds to a different product type, and the colors represent the levels of customer satisfaction, satisfied, neutral, and dissatisfied. This visualization allows us to quickly see how satisfaction levels vary across product categories. For example, groceries have the highest proportion of satisfied customers, while clothing has the fewest dissatisfied customers. Let's conclude today's lecture by discussing on pivot table. In Excel, it is a powerful tool for data analysis and summarization, allowing us to quickly analyze large datasets by grouping, organizing, and summarizing information. It helps users gain insights from raw data by creating reports that show totals, averages, counts, and other aggregations across different dimensions and categories. Here is a detailed guide on how to use and understand pivot tables in Excel. A pivot table is an interactive summary table in Excel that enables us to rearrange data dynamically by dragging fields around, aggregate data in multiple ways, such as summing, counting, averaging, or finding maximum and minimum values, filter data to display only specific information, analyze data across different categories and subcategories. Let's see how to create it. To create a pivot table, follow these steps. Step 1 is to prepare our data. Ensure your data is organized in a tabular format, with column headers. Avoid empty rows or columns in the dataset. Step 2 is to insert a pivot table. Select any cell in our data range. Go to the Insert tab in the Excel ribbon. Click on Pivot Table and choose the range of data you want to analyze. Select where we want to place the pivot table, that is either on a new worksheet or the existing one. Step 3 is to drag and drop fields. After creating the pivot table, you'll see a pivot table field list pane on the right side of the screen. Drag fields, column headers, into different areas. Rows are to define the rows of our table. Each unique value in this field will become a row. Columns are to define the columns. Each unique value becomes a column. Next is values, which defines the summary values. We can choose to display sums, counts, averages, etc. Finally, filters, that allows us to filter the entire pivot table based on a specific field. Let's understand the pivot table areas. Row labels that display the unique values from the chosen field as rows. Column labels which display the unique values from the chosen field as columns. Values shows the aggregated data, such as sums, counts, averages, or other calculations. Filters. Create a filter above the table that allows you to filter the data by certain criteria. Common aggregation options. When you drag a field to the values area, Excel defaults to summing numerical values or counting text values. You can change the aggregation by right-clicking on the field in the values area, selecting value field settings, choosing from options such as sum, count, average, max, min, product, standard deviation, and variance. Using pivot table features. Sorting and filtering. We can sort rows or columns alphabetically or by value. We can apply filters to display only specific rows or columns. Slicers. They are visual filters that allow you to filter your pivot table data by clicking on buttons. To insert a slicer, select the pivot table, go to the Pivot Table Analyze tab, and click Insert Slicer. Grouping data. Excel allows you to group data within a pivot table. For example, you can group dates by month or quarter, or group numerical data into ranges. To group, right-click on a row labels, and choose as Group. Pivot charts. Pivot charts are dynamic charts linked to pivot tables. They automatically update when the pivot table data changes. To create a pivot chart, select the pivot table, go to the Insert tab, and choose a chart type. Let's take an examples of pivot table use cases. Example 1 is sales summary by region. Suppose you have a dataset with columns like region, product, sales, and date. You can use a pivot table to sum up total sales by region, view product sales across regions, or analyze sales trends over time. Example 2 is employee performance. Imagine a dataset with department, employee name, performance score, and salary. A pivot table can help you find average performance scores by department, total salary by department, or the top performing employees. Pivot table formatting and layout options. Excel provides options to customize your pivot table's appearance. Design tab changes the style, apply banded rows, or display grand totals. Value field settings is used to customize the data format, example currency, percentages. We can change how subtotals and grand totals are displayed, as well as switch between compact, outline, and tabular forms for a cleaner layout. Let's check the limitations of pivot tables. Data size. Pivot tables may slow down with extremely large datasets. Limited to Excel data. Data must be within Excel's limits, example row and column limits. Not suitable for real-time updates. Pivot tables don't auto-refresh on real-time data, you need to manually refresh. Example diagram of a pivot table setup. Imagine the following data. With a pivot table, we can create summaries like total sales by region. In this table, in the region column we have North, South and East with the values 400,000, 200 and 400 respectively. Sales by product and region. Each report gives us insights based on how fields are arranged in rows, columns, values, and filters. In this we have different product like product A, product B, and product C with region North, South and East. In short, pivot tables in Excel are essential tools for data summarization and analysis, offering flexibility and a user-friendly way to explore complex datasets. They enable users to create quick reports without the need for advanced formulas or scripting. The interactive nature of pivot tables makes them ideal for extracting valuable insights, performing what-if analyses, and creating dynamic reports. In summary, this lecture covered data analysis. We learned topics like frequency distribution and histograms. We explored concepts like cumulative frequency, percentiles, cross-tabulations, and pivot tables. In the next lecture we will learn descriptive analytics. Stay tuned for the next lecture, where we will continue our journey through business analytics courses. If you want any other topic to cover, please let us know. If you have any queries related to this lecture, you can ask in the comment box, we will try to clear all your doubts. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more information on business analytic content. Your support is really important to us and it encourages us to make more educational stuff for you.